So last class we have been discussed about the threading and scheduling, right? So in that we have been defined what is meant by thread. Okay, so we said that a number of in a process which is going to be divided into number of some task is known as nothing but thread means each task is meant for thread and it is basically used for the CPU utilization. So for every thread, it is will be associated with some ID, and there will be a program counter and a set of registers and the stack itself. Okay, so in that case, the threads can be done as been divided into one process, one thread, and one process, multiple threads, and multiple process, one thread, and multiple process, multiple threads. Okay, so means these are all the functionalities of the threads. Okay, one process, one thread means it is a traditional approach, we can say that. And here it will be means one process will be meant for only one thread itself, single thread. And next one process, multiple thread means the process is divided into number of threads itself. And multi-process one thread means there will be multiple users of process one, but the thread process will be only one, means the thread one thread will be for the process. Okay, and the Java runtime, MS-DOS, Unix, all these are the examples which have been explained for you. But what happened at the time of scheduling, when we are discussing, the slides have given some problem, right? So that's why I'm going to recollect these things still more clear for you, clarity. Okay, so scheduling. Normally, when we say scheduling means giving means allotting some time. So for you also for your subjects for your course, as I said, for you, I given a best example for you. If the course is there are 5 courses for you, 4 subjects are there. We have given for different course different time slots so that you can utilize the maximum courses at your brain, maximum resources at your brains, everything. Okay, so here this scheduling is that much important. It's the most important related for the processing. We can say that. Okay, it is more important one which is related to the process. And for the main aim of the scheduling is to give some time for CPU. Why? Because whenever I'm going to do some processing system, okay, the CPU will be doing. But another time, it must be take some ideal state. We have to give some ideal state for the CPU. So that can be done from the scheduling one. Okay, so there may be a single single process system and multiple programming one. So in single process, what happens? One process can execute only at a one time. Okay, in another time the CPU gets a free. Whereas in multi processing systems, what happens and all the time of that the processing will be running and utilizing all the IO devices and also the processor one. Okay, why? What is the basic thing by using the scheduling means we can utilize the resources maximum. Okay, and whatever any pending task or a pending jobs are there, we can deal with that, and we can also process critical task based on the priority one. So by giving this scheduling one, what are the processing, we can utilize all those things. Okay, what are the thing means, once again I'm repeating, we can utilize the resources, we can have the we can deal with the pending tasks, and we can also have the critical task by giving some priority for that. So based on that we are going for the scheduling one. So in that we are having some scheduling queues. Okay, so scheduling queues, in that it is a ready process queue and blocked process queue and blocked swapped out ready process. So guys, when in the last class, if you remember, we have some a state diagram, right? Like a new will be there, next ready will be there, then running, then will be the terminated. So you have in a such a way that, right? So new to ready, ready to running, and running to the terminated. So in the new state, initially it is going to be start and it's going for the means you are ready for your exam. Okay, you have prepared whatever the thing. So when the running will be there, when you are going to write the exam. Okay, the terminated means the execution will be the final result itself. Okay, these are the states. In that, however, you have an preparation time, writing the exam and the final results, everything. So here also to do the processing, we have some states like new state, ready state, a running state, and the terminated state. So in that, these queues means it's a processing the line. There is different queues are used for scheduling. Okay, to schedule the processing one, there are different queues. What are the queues means? Ready process queue, the first one, as its name it suggests, the whatever the things, processing things, it is ready for that thing, ready for processing. Okay, it's not in enter into the running, it is ready to up to mark. Okay, blocked process queue means it is waiting. It's waiting for some accessing like IO operations or external accessing one. It is waiting for some time. Okay, that is blocked process queue. Whereas blocked and swapped out ready processing queue means it is in a ready state and also entered into the running, but waiting for the termination. So these are the three basic queue lines for executing of the processing. Okay, you are ready for the exam, that is ready process queue. Block process queue means you are waiting for the timetable, example timetable. And blocked and swapped out ready processing means you are ready and writing one. And you are waiting for the execution. So these are the three queues existed in the scheduling. Is it clear, guys, scheduling queues?
Yes, madam.
Coming to the scheduler one here. Second. Schedulers. So schedulers means it is a function of selecting a particular process from one state to another state. That is known as the scheduler. In that you have the long-term scheduler, short-term and mid-term. So observe here this one. So you have a long-term one, here the short-term and the medium-term scheduler. Okay. So now a new jobs or a new task has been entered. So that will come for the long-term scheduler. Okay, that comes for the long-term scheduler. So what this scheduler is responsible for processing the, means it will limit the processing stages. Limits, why it limits means so that for example 10 processes are there to be completed, 10 tasks are there. What it will do, it limits and send some 5 tasks to the ready queue. Okay, why ready queue means to get ready for next processing stage. అంటే ఇక్కడ కదా ప్రాసెసింగ్ స్టేజ్ అయ్యేది. సో ఇక్కడ ఏం చేస్తుందంటే it will select and limit some number of processings and send to the ready queue state. So that what happens, the CPU gets some reduced one, అంటే ఆ టాస్క్ పర్ఫామ్ చేయడానికి ఉన్న CPU కి it will give some time. We are going to give some time for CPU. That is known as a long-term scheduler. Means long-term scheduler is responsible for limiting the tasks which are giving for ready queue and through the process system. Okay, this is the long-term scheduler. So now from new job, that is this one new task, we can say that from that we are going for long-term and we are going to limit. Means as I said, for you have 10 tasks, I am limiting for 5 tasks itself. Okay. So what it means, it disallows the processing one beyond some limit itself. Okay. Coming to the next. So that what happened, the basic importance for the long term means it will be some, means it will give some time for the processing one, that processor. Next, short term scheduler. So where is the short term scheduler? It is there after the ready queue. Okay, so here this scheduler will be deciding from ready queue to the processing, means it is bothered for the executed one, means whatever the things coming from the ready queue, the processing, as 5 processing we have been selected, that is limited from the long term, right? So those things are given for the processor and here we are going to meant for the execution, meant for the execution, meant for the execution. Or execute, you can say. That is a thing for the short-term scheduler. Okay, long-term scheduler is starting it straight from the initial. Short-term is meant for the execute, and medium-term is between the long-term and the blocked and ready swapped process. So as I said for you, this blocked and ready swapped is nothing but you're ready and entered into the running state. Okay, you are into the ready and the running state itself. So medium will be in between the long term and this queue, that is blocked and ready swapped process. So why all these things, why medium shell, everything means to make the processing stage from new to terminated one. So in between what we are going to do, how we are going to maintain, That those the processing is known as the scheduling. Is it clear, guys? Is it clear?
Yes, madam.
Now we'll go for scheduling criteria. It's a basic important one, ma. Based on these performance metrics, today I'm going to deal with one of the algorithm. So here, this scheduling criteria is also known as the scheduling methodology. So there will be many algorithms existed, that is processing algorithms, as we are dealing with the processor, right? So there are many scheduling algorithms available, and this different scheduling algorithms will have the properties. What are the properties? Means this one: throughput, run around, waiting time, response time, CPU utilization, and processor utilization. So first of all, throughput. Throughput means it's measured the number of, means how many, we are dealing with the processing, I said, na? So it deals with the how many process has been done per unit. Okay, how many process have been executed per unit of time. Per, per unit of time. Okay, so in throughput, we are observing that how many number of process have been executed per unit of time. Each process is considered with the based on the time. Okay, next is the turn around time. Next is the turn around time. So turn around time, that is shortly we can call it as a TAT, ma. So TAT is equal to, please be careful at this, so that based on all these properties, the scheduling algorithms is explained with different examples. So you'll come across that. So be careful in observing these metrics, performance metrics, or the properties, we can say that. So turn around time is waiting time, waiting time in ready queue. Means ready queue is the initial one. After new state, you will be observing the ready queue, right? So ready queue plus executing time, plus executing time, plus means it is all the sum of turnaround, is nothing but it's a ratio around, it's taking the sum of waiting time in the ready queue. Okay, next executing time and waiting time, and waiting time, waiting time queue for IO, that is input and output. Okay, this is the turn around time. Means it is a time interval taking between the ratio of the submission of the process where you have been started and time of the completion, and time of the completion. So it takes the interval between the time interval between the submission, submission and completion, and completion. It is a time interval taking between the submission of the process and the completion of the process is known as the turnaround time, or we can take as a sum of the waiting time in the ready queue and executing time. Okay, and waiting time queue for IO operation. IO operation. This is the turnaround time. Next, waiting time. Next is the waiting time. So waiting time is nothing but it is sum of the periods where we are waiting for the process, where we are waiting for the process. That is known as the waiting time. We are waiting for the process to be executed or to be submitted, everything. Okay. Next, response time. So response time means it is a time duration for submission of the first response. So as I said, for you have been sent something for you at the time of 11 o'clock, 11:30. My class is there. So we have been started at 11:35. So the difference, the ratio, I mean, where have been started the class. So it's a ratio between, I mean, difference between from 30 to 35. So 5 minutes is there now, that is the response time. Okay, next is CPU utilization. CPU utilization is nothing but this is taken in terms of person time. Okay, the time that process is busy. Okay, next, process utilization means it is the ratio between, we can take that processor, 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 processor busy time by by process visit time plus process ideal time. All of you note all these formulas, it is important for you. Okay, once again I'm repeating. Process visit time, it is a ratio between the process visit time by sum of process visit time and process ideal time. This is the process utilization. Okay. Is it clear for you all? So overall we can say that we have to have the CPU maximum utilization and maximum throughput will be there. Okay, and the turnaround time. This turnaround time must be minimum one. Waiting time must be minimum, and response time must be minimum. Rest of the thing must be in a maximum, max. Okay, is it clear, guys?
Yes, madam.
Okay, one girl has been asked again to repeat. So throughput is nothing but we are going to means where the processing whatever we are going to execute the task. So the process is taken in terms of time. Per unit of time is known as the throughput. This must be in a maximum way. Okay, and next turn around time means is nothing but it's a ratio taken between the sorry interval taken between the submission time to the execution of the time. Okay, so that must be very minimum so that the task can be performed very fast. And waiting time means we are waiting for the means the process is waiting for execution. So this also must be in a minimum way. And whereas response time means when it's a time duration where we have been submitted the first response, where we have given the first response, where we have been presented the first response. So this response time also should be minimum, and CPU utilization must be maximum way where we can um, utilize the maximum resources, everything. And the last, process utilization is nothing but it is taken ratio between the processor visit time to the sum of processor visit time plus ideal time, processor ideal time. Okay, this one also must be in a maximum way. So based on this, all these performance metrics, we are going to in detail about the scheduling algorithms. Is it clear now? The girl who has asked the doubt, is it clear? Shall I continue? Now, coming to the scheduling algorithms. I'll explain here. That's why I'm using this one. So scheduling algorithm may be a preemptive and non-preemptive. I said for you what is meant by preemptive and non-preemptive, right? So in non-preemptive, what happens? Whatever the CPU which is assigned some processing, so that does not do not release until the submission. I mean execution has been done. Whatever the processing stages is there, it has to be submitted and it has to be executed. Until unless it is not going to release anything. Okay, whereas preemptive, there it will be some priority based one. Okay, based on that it will be replacing, okay, releasing everything. So that is going to be done under your preemptive. So now all these scheduling algorithms may be preemptive or non-preemptive. Okay, so the first is nothing but first come first serve scheduling algorithm. Next one is shortest job first, and next one is shortest remaining time and round robin, priority scheduling, multi-level queue scheduling, multi-level feedback queue scheduling, multi-process scheduling, and real-time scheduling. All these are there. So I'm going to deal with the first one, that is first come, first serve. First come, first serve. So it is the scheduling algorithms, which is a basic simple one. Okay. So in this algorithm, what happens? We are setting the processing in the ready state. Okay, and we are managing the state to be first in, first out, like first come, first serve, like that. So whatever the processing is there in ready state, we are going to manage as a first in, first out. So how it will be there in this means, for example, there are like 1, 2, 3, 4 processing stages. So the first will be the first, right? So it will come as a 1, 2, 3, 4. So to the processor, it will go in this order. Here our processor will be there, that is nothing but CPU ma, and this is the executed one. Okay, in this manner we are going for in the scheduling algorithm, that is first come first serve. Okay, first in first out or first come first serve, whatever the initial one, whichever is going to one, that will be completing its task. Okay, and this whatever the processing, the implementation, it's very easy in this first come first serve. So here I'm going to deal with some of the example, one of the example for you, how it is going to be dealing, how we are going to say it is a preemptive or non-preemptive, and how we are going to implement all those performance metrics, everything. So now the example which we are going to consider, if you have a textbook, you can open page number 215 also, not a problem for me. Okay. So there we are considering some set of process, okay, that at a time 0, okay, initial time is given as a 0, and with the length of the CPU burst time in milliseconds, okay, in the milliseconds. I'm going to draw the table also. This is the brush time. So what I'm going to take, I'm going to take an example that some set of process are there. What are the processing means? I can say P1, P2 and P3. Okay, so these are going to arrive at the time 0 with the length. Okay, and the burst time will be in the milliseconds. So generally burst time is nothing but it refers to the time required in a milliseconds for the execution of the process. Okay, and now what we are going to do, if the order, as we are dealing with the first come first serve, so in that, if you take a chart, what happens, which processor will be in the first one, initial one, which will be there, anyone, can you tell me? In first come first serve, these are all the processing stages. So first, which one will be there?
P1,
Next, P2.
P2,
Next,
P3.
P3. Let us take the length has been started from 0 to 32. As here, P1 brush time is, sorry, I forgot to give, that is 24, P2 is 3, and P3 is 5. Okay, so P1 is brush time is 24, means it start from 0 to 24, and next P2 it start means it is 3, means 24 plus 3, that is 27. Okay, that is P2 1, and next P3 is 5, means nothing but 27 plus 5, that is 32. So completely this is the chart defined, means processing time defined for the process, that is P1, P2, P3. Okay, this is the given one ma. This is a given one. What is that? There are 3 processing, and the burst time is 24 milliseconds for P1, and next 3 milliseconds for P2, and P3 is 5 milliseconds. So when we are saying that first come first serve, okay, the processing time taken for the first one is 0 to 24 milliseconds. Next, when we are going for P2 processor, so what happens? The P2 means nothing but it's coming from here, right? Initially, how? P1, P2 and P3. So it is also in the same line. So that's why 24. And what is the time here? 3. That's why plus 3, 27. Next, P3 is 5, means 27 plus 5. That is 32. Okay, there is a chart we processing arrived in this order, we are saying. This is the question and this is the answer. Solution started from here. Now what we have to do means, whatever we got, this is the throughput. Means we know that throughput is nothing but the processing done per 1 unit, per unit of time, sorry, per unit of time. Now we want to find the TAT, nothing but turnaround time. Now, in turnaround time, the process, the first task of the P1 is 24, P2 is 27, and P3 is 32. Okay, if you take average all these, means that is 24 plus 27 plus 20, 32. Can anybody say what is the sum of this one? 24 plus 27, 50, 51 now. 51 plus 32. Tell me.
83.
83 by 3. So it will be around like 3 2s are 6. Again 2, 23. 7s are
27.6.
6. Okay. Now means this is the average one. Average, we have taken average time, we are saying as a 27.6. Now, this is the turnaround time. Next, if I take waiting time, how much time waited for executing of that process? We'll discuss about this. Waiting time. So first initial P1 is started with 0, right? So there is we can say that the P1 is waiting time is 0. For P2, what will be there? Can anybody tell me? What is the waiting time for P2?
3.
No, that is a burst time that has been given after chart. 24, good, Bhavani. Well tried, someone has said 3 now. Okay, let it be. You are on the class, right? That's us happy. Okay, don't mind. Next to P3. Now you tell me what is the time taken for P3? 27, good.
27.
Very good, very good. Arun Prasad, good. Now, take all this, I mean, average one, that is 0 plus 24 plus 27 by 3. Can anybody tell what is the sum? 51 by 3. Nothing but you are going to say 17 milliseconds. Guys, don't get confused. This is the problem which has been given. That is, three processes are there. The burst time is 2435. Okay, burst time is nothing but to complete the CPU process in terms of milliseconds. After that, what we are going to do, we are going to have the chart based on starting 0 to 32. How we got this 32, 27 means this P1 is initial 24. When we are going for P2, it will add 24 plus 3, that is 27. For P3, 27 plus 3, 32. Okay, so we have averaged all these 24, 27 and 23. Next, for waiting time means that initial one, that is 0 for P1, 24 for P2, 27 for P3. Okay, next, what we can take, if the process is arrived, based on the, I mean, like this, I'll show how many. My mouse is giving it. Where it is. Yes. Let us see if my order is like this P2, P3 and P1. Rather than my order is like P1, P2, P3, if my processing state is P2, P3, P1. Now you tell me how it will be there, the chart. I think that this time is doesn't sufficient for us to explain. P2, P3 and P1. Initially it is 0. P2 start with 3, right?
Yes, madam.
What is next to P3 burst time is 5. So how it will be there? 3 plus 5, 8. 8 plus 24, 32. Hence, this chart is based on the first come, first serve. We have to take, for example, here, if you observe 0 is the initial one, 24 is the time taken for pre-1. And when we are going for P2, it is a 3 means 24 plus 3. Similar way, for P2, it has been started. We have taken another one. Now, let us think that processing stages P2 has been started. So, 0 will be there. And then P2, the time is 3 now, exactly 3 write down. P3 means 3 plus 5, 8, and P1 means 8 plus 24, that is 32. And now the work for you, find out the TAT and waiting time for this. Maybe our class may be ended within 3 or 4 minutes. That's why what I'm giving the work for you. Find out TAT and waiting time for this one. Okay. Find the
Okay,
TAT
madam.
and don't copy from your textbooks, guys. Just try for you. And also, I'm giving one more assignment for you. Uh, Guys, assignment for you. All of you, you have to show me. I'll create a Google Classroom for you. So based on this P1, P2, 1042, this is the burst time, and this is the processing one. So you just find out TAT and waiting time. Okay, the serve is, I mean, first serve means P1, P2, and P3. Okay. You just tell me and you just go through this. If you have any doubts, I'll be clarifying in the next class, or if possible, I'll be taking a class in the afternoon. Okay. So please share your doubts or anything, ma. Is it clear for you all?